Hello students, in this video we are going to discuss numerical problem number 24 from chapter of Newton's laws of motion from book Nootan ISA Physics. Now students, here the question says a child suspends a steel disc. So what you can see over here, there is a steel disc which has been suspended in a vertical plane. So this is a steel disc. This has been suspended in a vertical plane with the help of some thread. So this is a thread, and he shoot a bullet. So this is the bullet which has been shot, and this bullet has got a mass of 2 grams. So bullet has got a mass of 2 grams, and the bullet is moving with a velocity of 11 meter per second. So this bullet moves with a velocity of 11 meter per second and returns with the same velocity. So what happens there, after the bullet is going to return back, and this bullet also returns back with the same velocity of 11 meter per second. I would not use the word velocity, same velocity, instead should be same speed, okay? Because see, velocity combines speed plus direction. तो ये थोड़ा न्यूटन फिजिक्स की गंदी इंग्लिश है, wrong English over there. So the bullet returns with the same speed. Then what we require, we want to know that the force exerted by this bullet onto the disc, and then and it's been given that the child is firing 3 bullets per second. So that's the question is. So student, once again, what's are the learning objective? The learning objective of all these numerical problems that I have been discussing with you all is basically making you understand that momentum is a vector quantity. So don't forget that. Always use the sense of direction apart from magnitude. So it has got both magnitude plus direction. ठीक है ना बच्चों? स्टडीज भी एक वेक्टर क्वांटिटी, उसके साथ मैग्नीट्यूड की भी जरूरत होती है और डायरेक्शन की भी जरूरत होती है, तो याद रखिएगा. मोमेंटम इज आल्सो अ वेक्टर क्वांटिटी, हैज गॉट मैग्नीट्यूड, रिक्वायर्स मैग्नीट्यूड एज वेल एज सेंस ऑफ डायरेक्शन. ओके. सेकेंडली, यू शुड अंडरस्टैंड दैट फोर्स is equals to delta P by delta T, that is the Newton's second law of motion. This is also a learning objective that is going to come from here. And the third thing, you should understand that force that A exerts on B must be equal and opposite to force that B exerts on A. That is the action reaction pair. So these 3 learning objectives are to be understood by this particular question. So let me just put up all these things with reference to this particular question. So mass of the bullet is 2 grams. The initial velocity of the bullet, let me write down as U, initial velocity of the bullet happens to be 11 I cap. 11.0 meter per second I cap. So what you can see over here, the bullet is traveling towards the right, and see, this is the sense of direction that we are going to follow. This is my reference frame, X and Y. So 11 meter per second I cap, and it returns back with the same speed. So the final velocity happens to be 11.0 meter per second minus I cap. So it is now, after striking, the bullet is returning in this direction, negative x-axis. So let me just go ahead and find out the initial momentum first. What is the initial momentum? That is the mass of the body into velocity of the body. What is the mass of the bullet? That is 2 grams. So 2 upon 1000 into initial velocity is 11 I cap. So that becomes 0.022 I cap kg meter per second. Please don't forget to mention the unit. Without unit, the answers is always considered wrong. Okay. What will be the final velocity? Let's calculate the final velocity. Let's calculate the final momentum. Mass into final velocity. Once again, this things remains the same. Mass remains the same. Now the velocity changes the direction. So 11 minus I cap, and once I am going to solve it, this should come out to be 0.022 minus I cap kg meter per second. So what is the change in momentum, students? So change in momentum becomes final momentum minus initial momentum. So what is the final momentum? The final momentum is minus 0.022 I cap. Initial momentum is 0.022 I cap. So that comes out to be minus 0.044 I cap, or simply one can write down 0.044 minus I cap kg meter per second. Remember, again and again I have been telling you that whenever you are writing down, when you are having dealing with vectors, or when you are writing down the vectors with negative sign, the negative sign is there just to tell you the sense of direction. Please take care about this particular fact. Now this is the change in momentum, and we found this change in momentum by keeping the fact into our mind that momentum is a vector quantity, possesses both magnitude as well as direction. Now I am looking forward to find out the force. Now force exerted by the bullet on the steel disc. So force is equal to delta P by delta T. Now if you see, the number of bullets fired in 1 second happens to be 3. This is the change in momentum experienced by one bullet, isn't it? So change in momentum experienced by 3 bullets. So this will be 0.044 into 3, and that happens to be 0.132 kg meter per second in minus I cap direction, isn't it? Because in 1 second you are firing 3 bullets. So the force exerted by these 3 bullets in 1 second will be 0.132 divided by 1 second, because the time interval in which these 3 bullets were fired is 1 second. So the force exerted by the bullet will be 0.132 Newton. Is that clear? So please take care about this fact. And since, see, this is the force experienced by the bullet, whatsoever the force experienced by the bullet will be the force experienced by the bullet on the disc also. This is the force experienced by the bullet, and this much is the force transferred by the bullet to the disc also, because force exerted by A on B will be equal to minus times the force exerted by B on A. The minus sign is there to tell you the sense of direction, that if it applies along the positive x-axis, then B will apply the force on A in the negative x-axis. Okay, so I hope this solution would also make you understand about all these 3 learning objectives which I have already stated earlier. Thank you very much, students.